Let's go over practice questions on forces and Newton's laws of motion. The first one here, a car traveling at a speed of 54 kilometers per hour is brought to rest in 90 seconds. The first question is to find the deceleration. So we've been given the initial speed. This car is traveling at 54 kilometers per hour. So the first thing we should be able to do is to convert this velocity we've been given to the SI unit, that is the meters per second. So we're going to multiply. We see we've got a kilometer on top. We're going to put a kilometer down and then a meter on top because we want to convert to meters. In 1 kilometer we have got 1000 meters, and then we're going to convert the hour. Now the hour is in the denominator, so we're going to put the hour on top and then second down. In 1 hour we've got 3600 seconds. So the hour and the hour cancels, kilometer and kilometer also cancels. This is going to give us an initial velocity of 15 meters per second. Now the question is saying is brought to rest, meaning that the final velocity is going to be equal to 0, and also been given the time, that is 90 seconds. We want to find the retardation or the acceleration. So retardation, acceleration first is given by final velocity minus initial velocity divided by time. So this will give us final velocity is 0, the initial velocity is 15, the time is 90. So what we have is negative 15 over 90, that would be negative 0.166 meters per second. Now the question is saying retardation. Just the word retard means negative acceleration. So therefore we're going to say the retardation is equal to, or just write a positive value, 0.16. You can say 67 since the sixes continue to go like that, meters per second. So just the word retard means negative acceleration, or the word decelerate. And the next question is saying find the distance traveled. So the distance traveled, from the data that you've been given, you can say 2as is given by v squared minus u squared. So be 2, the acceleration will determine negative 0.1666. So when you are using the value that you calculated, don't use the rounded off value, use the exact value. Then multiply by the distance. This is going to be equal to final velocity is 0, initial velocity is 15 squared. So this is going to, we're going to divide both sides by 2 multiplied by negative 0.1666. Also this side by 2 multiplied by negative 0.1666. So this term and this term cancels. The distance we're going to get is about 675.0675 meters, which we can just say as 675 meters. And the next one, the speed limit along a certain road is 80 kilometers per hour. To stop at a junction, the driver applied excessive force on the brakes and skidded for 55 meters before stopping. The coefficient of kinetic friction between the tires on the road is 0.75. Want to determine if the driver exceeded the speed limit. So here is a vehicle that is moving forward with a certain velocity v. Okay, let me call it u because it's initial velocity. Now, the driver applies excessive brakes. The brakes are going to give the vehicle a force of friction that is going to be stopping the vehicle from moving. Now, before the vehicle can stop moving, it has to skid for 55 meters. And then the final velocity is 0. Now, want to find first this initial speed and then compare it with the speed limit to see if the driver exceeded the speed limit or not. The first thing that we're going to work with is we're going to work with the forces acting on this vehicle in the forward and back direction. So we're going to say net force in the x direction on this vehicle is given by, we don't have any forward force because the driver applied brakes, so there is no forward force, that is 0. And then we are going to remove any backward force. So the backward force that is acting on this vehicle is the friction which arises due to the brakes which have been applied. Now the net force is given by mass multiplied by the acceleration, and this is going to be equal to negative friction, and friction is given by coefficient of kinetic friction multiplied by the normal force, and normal force is given by mass times gravity. So here the mass and the mass cancel, so acceleration is equal to negative mu k multiplied by g. So the acceleration is going to be negative mu k. The coefficient of friction is given 0.75, g is 9.8, and this will give us negative 7.35 meters per second squared. Now we can see the value is negative. That is because the vehicle was going to a stop, so there was a deceleration. Now that we found the acceleration, we can determine the initial speed, and we can say final velocity squared is given by initial speed squared plus 2as. Final speed, we know this is 0, the initial speed is what we want, plus 2, acceleration is negative 7.35, and then multiply by the distance before stopping, so it moved 55 meters. We're going to multiply those, so we're going to get u squared minus, this is 323.4. We'll take now this term the other side. That is going to give us u squared being equal to positive 323.4 square root both sides. So u is going to give us about 17.97 meters per second. Now I cannot compare the meters per second with the kilometers per hour that is being given. So it is either I convert this kilometers per hour to meters per second, or I convert this one to kilometers per hour, so that we can now be able to compare them. So let's just convert this one. So we're going to multiply. We've got a meter on top, we put a meter down, then a kilometer on top. In 1 kilometer we've got 1,000 meters. So the meter and the meter cancels, and then we have got a second down, we put a second on top, and then an hour down. In 1 hour we've got 3,600 seconds. The second cancels. So this will give us an initial velocity in kilometers per hour of about 64.8 kilometers per hour. So this is the velocity at which the vehicle is moving before stopping, and this is the speed limit. This means that the speed limit was not exceeded, because we can say the speed limit is higher than the velocity at which the vehicle is moving. Question number 3. Two forces F1 and F2, F1 which is 4 newtons and F2 which is 3 newtons, acting on a 5 kg block as shown. Determine the acceleration produced. So in this first case, what will be the acceleration produced? So to be able to determine the acceleration, if you have got a force, one force is going up, and this is the F1 which is 4 newtons, and then another one is going in this direction which is 3 newtons. We first need to find the net force acting on this object. So to be able to determine the net force, we can continue this, we can extend it like that, and then we can also extend like this. So the net force is going to be produced in this direction. And to be able to determine that, we're going to use the Pythagoras theorem. So this is going to be the net force that will be acting on the object. So we'll say the net force is given by using the Pythagoras theorem. So if this is 4 newtons, meaning that even this side is going to be 4 newtons, this is the hypotenuse. So it is going to be 4 squared plus a 3 squared, and then we square root. And this is going to give us a net force of 5 newtons. Now, using Newton's second law of motion to determine the acceleration, you know that force is given by mass multiplied by the acceleration. So the net force is what we use, that is 5 newtons. And that will be equal to the mass, that is, we've been told this is a 5 kg object, multiplied by the acceleration. So divide both sides by 5. The acceleration is going to be 1 meter per second squared. In the second scenario, also we need to determine the net force. Now for this one, since these forces are making 90 degrees to each other, we're going to subtract them. So the net force is going to be given by a forward force, which is F2, and we know F2 is what? F2 is 3 newtons, minus the backward force. Backward force is 4 newtons. So the net force is going to give us negative 1 newton. So to find the acceleration, force is going to be given by mass multiplied by the acceleration. Force is negative 1, and then the mass is 5 multiplied by the acceleration. So this will give us, if we divide both sides by 5, the acceleration is going to be equal to negative 0.2 meters per second squared. The reason as to why the acceleration is negative is because if we take that motion, this object is supposed to be going in this direction, the force pulling it behind is greater than the force that is supposed to pull it forward. That's why the acceleration is negative. Or take it like, take the force going in the positive x direction as positive, and then the one in the negative direction as negative. That is why this value is what? Negative, because the one going in the negative x direction is bigger than the one which is going in the positive x direction. If we consider also this one, we need to find the net force. Now the net force in the x direction for this one, you can see both forces are going in the same direction, so it will be 4 plus 3. They're going to add up, and that is going to give us 7 newtons. Then to find now, force is given by mass multiplied by the acceleration. The net force is 7. The mass is 5 multiplied by the acceleration. Divide both sides by 5. Acceleration is going to be about 1.4 meters per second squared. So that is it for this one. Question number 4. A 1000 kg car accelerates from rest to 10 meters per second in 7 seconds along a straight line. How large a force is needed to achieve this? So we know that for us to be able to find force is given by mass multiplied by the acceleration, but we don't know the acceleration in this question. So how do you find the acceleration? So this is going to become force is equal to mass. We know that the acceleration is given by final velocity minus initial velocity over time. So the force therefore is going to be mass is 1000 multiplied by final velocity. It accelerates from rest to, so meaning the final velocity is 10. It came from rest, the initial velocity is 0, and it took 7 seconds to do this. So therefore the applied force is going to give us about 1428.6 newtons. So this is the force that is required to make this acceleration. Question number 5 here. An 8 kg wagon is pulled by a force of 20 newtons at an angle of 40 degrees above the horizontal. Determine the wagon's acceleration. Now, we are pulling this by a certain force of 20 newtons above the horizontal. So, whenever you are pulling something at a certain angle, the force at which you are pulling it is going to be broken into components. So, we are going to have the x component. We are also going to have the y component. So we need to find these components, and x component is given by force cos theta. So this is going to be the force applied is 20, cos the angle is 40, and this is going to give us 15.32 newtons. And then the component in the y is going to be given by force sin theta, and the force is 20, sin the angle is 40. This is going to give us about 12.86 newtons. Now, if we look at this object, let's try to determine its weight. So the weight of this object is going to be given by mass multiplied by the gravity. So if you look at the mass is 8 kg, let's just take gravity as 10. So 8 times 10 is 80, meaning that this component that is going up is smaller than the weight of this object. Because of this component going up will not be able to lift this object upwards. So this object will just be able to move forward. It will not go up or down. Why? Because the component in the up direction is not big enough to lift the object. Alright, so for us to be able to determine the acceleration of the object, we are going to use the force in the x direction. It will only be moving in the x direction. It will not move up or down. So force is given by mass multiplied by the acceleration, and the force we are using here is 15.32 because it is only moving in the forward direction. So you use the component going in the forward direction. Don't use the force given. And this is going to be equal to mass, which is 8 multiplied by the acceleration, and divide both sides by 8. The acceleration therefore is going to be 1.9 meters per second squared. And then for the second part, we want to determine the reaction force the ground exerts on the wagon. So the ground is going to exert a force on the wagon, or in other words, we want to determine the force that is going to be able to balance the weight force, because this object has got a weight, so there should be a force balancing it up. The only way something is not, this thing has got a weight force going down, the only way it is not going in the ground is because there is a force that is also balancing it going up. So this is the reaction force. So to be able to determine this reaction force, we are going to look at all the forces in the y direction. So first, let's talk of the forces going up. The first force going up, we have got the reaction force. The next one, we have got Fy. And then downward forces, we only have the weight force, and weight force is given by mass times gravity. Now, because this object is not going up, we know that net force is given by mass times acceleration. So there is no acceleration in the y direction, that is, it is not moving up or down. So this is going to be 0. And the reaction force, we don't know. The force in the y, Fy, we found 12.86. Then minus mg, mass is 8, g is 9.8. So this will give us 0 being equal to r. So if we say 12.86 minus this number multiplied by this, we'll just compute together that operation. That is going to give us negative 65.54 newtons. So to be able to find r, we're going to take this term the other side. Therefore, r is going to be equal to 65.54 newtons. That's the reaction force. Question 6 here. Two blocks A and B are in contact on a frictionless surface and they've got masses 2 kg and 4 kg, meaning that this one is 2 kg, then the bigger one is 4 kg. A force of 12 newtons is applied to block A. What force does block A exert on block B? So the first thing, to be able to find the force that this one is going to exert on the other, we need to find the acceleration of the system when we apply a force. So force is given by mass multiplied by acceleration. And the force that we are applying is 12 newtons. The mass, since these objects are in contact, we are going to add these two masses. That is going to give us 6. And then multiply by acceleration. Divide both sides by 6. Acceleration is going to be 2 meters per second squared. So now to work us that block A is going to exert on block B. Again, we know that force is given by mass multiplied by the acceleration. So this force is what we want. Now the mass we want to exert on block B, the mass of block B is what? Is 4. And then the acceleration of the system is 2. Meaning that the force that will be exerted on B is 8 newtons. So this same force exerted on B is the same force that B is going to exert on A, but they are going to be in opposite directions. So the force B exerts on A is going to be negative 8 newtons, but A on B is going to be positive 8 newtons. It's the same. And then for question B, saying if the same force is applied on block B, what force does block B exert on block A? So if we apply this force in this direction, so the acceleration of the system is going to be the same because the total mass will still be the same, 6. So in this case, the force exerted on block A is going to be mass of block A, that is 2, multiplied by the acceleration. The acceleration is still 2. So the force therefore is going to be 4 newtons. This is the force that is going to be exerted on block A if the force is applied on block B first. Alright. The speed of a nerve impulse in a human body is 100 meters per second. If you accidentally stab your toe in the dark, estimate the time it takes the nerve impulse to reach your brain. What would happen if the speed of the nerve impulse is much lower, say 1 meter per second? Assume you are 1.7 meters tall. So say this is a person who is 1.7 meters tall. So when you stab your toe, the nerve impulses are going to come from rest, start from rest, and then they're going to travel, they're going to reach the brain with a velocity of 100 meters per second. And this person is 1.7 meters tall. Okay, we want to find the time it is going to take for the nerve impulse to reach the brain. So to be able to determine that, first we need to find the acceleration of the nerve impulse. So velocity squared is given by initial velocity squared plus 2 acceleration multiplied by the distance. Final velocity is going to be 100 squared. The initial velocity is 0 plus 2 acceleration. We don't know the distance or the height of the person that the nerve impulse is going to travel is 1.7. So this is going to give us, this is going to be 10,000, and that is going to be 2 multiplied by 1.7. So it's going to be about 3.4 A. Divide both sides by 3.4, therefore A is going to be 2941.1 meters per second squared. We found the acceleration of the nerve impulse. Now to find the time, we know that velocity is given by initial velocity plus acceleration multiplied by time. The final velocity is 100. Initial velocity is 0 plus acceleration is 2941.1, and then multiply by the time. So divide both sides by this value 2941.1 to find the value for t, and that would be 100 divided by 2941.1. That is going to give it about 0.034 seconds. This is the time that is going to take for the impulse to reach the brain. Now, what would happen if the speed was much lower, say 1 meter per second? So if it was like that, let's first determine the acceleration. Final velocity squared is equal to initial velocity squared plus 2 acceleration times distance. So final velocity is 1. That is the one we're talking about. We assume it is 1. The initial is 0 plus 2 acceleration. The distance is still 1.7. So this is going to give us 1 being equal to 3.4 a. So divide both sides by 3.4. The acceleration is going to give us about 0.29411 meters per second squared. So to find the time, final velocity is going to be equal to initial velocity plus acceleration multiplied by time. Final velocity is 1, initial is 0 plus acceleration 0.29411 multiplied by the time. So divide both sides by this value, which is 0.294. So 1 over 0.294, the time is going to be about 3.4 seconds. So what would happen if the speed of the nerve impulse was much lower? We can see if the speed is much lower, it is going to take a bigger duration for the impulse to reach the brain, meaning that your reaction time is going to also be more. For example, if you stab yourself, instead of you being able to remove your feet there and then, because the brain has not yet recorded the incident, it will take time for you to react to the pain or for you to feel the pain. So this is what happens. But if the speed is much higher, just when you stab yourself, your brain is going to receive the information and you are going to be able to react to the pain. Okay. Question number 8. A horizontal force of 140 newtons is needed to pull a 60 kg box across a horizontal floor at a constant speed. So here is the box. A horizontal force of 140 newtons is required to pull this 60 kg object. Now the statement given here is constant speed. What is the coefficient of friction between the floor and the box? So for us to be able to calculate the coefficient of friction, meaning that there is a friction here, a kinetic friction, because this thing is moving at constant speed. So if it wasn't moving, then the friction would be talking about is static friction. So we are going to talk about the net force. Net force on this object in the x direction, because it's just moving in the x, is given by applied force minus friction force. Now, because this object is moving at constant speed, whenever we've got constant speed, there is no acceleration. So every time we have got constant speed, because acceleration is given by final velocity minus initial velocity over time, if the velocity is constant, meaning that the final value is the same as the initial value. So if you subtract them, they're going to give you 0. So the net force is given by mass times the acceleration. The acceleration is 0, meaning that the net force is also going to be equal to 0. Applied force is 140 minus kinetic friction is given by coefficient of kinetic friction times normal force. Normal force is given by mass times gravity, and the mass is 60, gravity is 9.8. Okay. So this is going to give us 0 being equal to 140 minus, I'm going to write this as 60 times 9.8, and then I'll put mu k. I'll take this term the other side of the equation so that it becomes positive 60 multiplied by 9.8 multiplied by mu k, and that will be equal to 140, and then divide both sides by 60 multiplied by 9.8. So that will give us coefficient of kinetic friction of about 0.238. Coefficient of friction doesn't have a unit. Alright, question number 9. Police investigators examining the scene of an accident involving two cars measures a 72-meter long skid marks of one of the cars, which nearly came to a stop before colliding. The coefficient of kinetic friction between the rubber and the pavement is 0.8. Estimate the initial speed of the car assuming a level ground. So here you've got a car. Okay. Let's say this is the vehicle which was moving in this direction at a certain velocity which we don't know. But when it saw another car, when the driver saw another car which was coming, the driver applied brakes on the car. But it didn't just stop there, and then it had to skid for 72 meters distance. And then it nearly came to a stop. So I'm going to take that the final velocity is now 0. It has come to a stop. And because the brakes were applied on the car, there is a force pulling this car in the opposite direction, and that force obviously is friction because it is stopping the car, and this car is moving, so that is going to be kinetic friction. So this is initial velocity, VO, or I can say U to mean initial velocity. So I want to determine the initial velocity. So the first thing that we're going to do is we're going to work with the net forces on this object, on this car. Net force is given by forward force, there was no forward force, and then minus backward force, we have got kinetic friction. And the net force is given by mass multiplied by the acceleration. Kinetic friction is given by negative coefficient of kinetic friction multiplied by the normal force, because this is a level ground. Normal force is mass times gravity, so the masses cancel out. Acceleration is going to be given by negative mu k multiplied by gravity. Acceleration is going to be negative mu k, coefficient of kinetic friction, we've been told that's 0.80, and then g, that's 9.8. The acceleration therefore is going to be negative 7.84 meters per second squared. And then we can now determine the velocity. Velocity final is given by velocity initial plus 2 acceleration multiplied by the distance. Final velocity is 0. The initial velocity is what we want, plus 2 acceleration is negative 7.84, and the distance moved before stopping is 72. So I'm going to take this term the other side of the equation, so I'm going to remain with u squared. And if we multiply 2 by negative 7.84 by 72, we're going to get 1128.96, and square root both sides. Initial speed is 33.6 meters per second. So this is the initial speed. Alright, a person has a reasonable chance of surviving if the deceleration is no more than 30 Gs and G is 9.8 meters per second squared. Calculate the force on a 70 kg person undergoing this acceleration. What distance is traveled if a person is brought to rest at this rate from 100 kilometers per hour? So since I've seen one velocity is brought to rest, from, so meaning that the final velocity is going to be 0, but the initial speed we've been given 100 kilometers per hour. Let me convert it first to meters per second. Put a kilometer down, a meter on top. In 1 kilometer I've got 1,000 meters, so this will be able to cancel with this, and then we convert the hour. The hour is down, we put it on top, and second down. In 1 hour I've got 3,600 seconds. The hour and the hour is going to cancel, so this is going to give us 27.78 meters per second. Now a person has got a reasonable chance of surviving if the deceleration is no more than 30 Gs. So the deceleration is no more than 30 Gs, and then calculate the force on a 70 kg person undergoing this acceleration. How do we find force? Force is given by mass multiplied by the acceleration. So the force is going to be equal to the mass on a 70 kg person, so 70. The acceleration we are talking about is if the deceleration is no more than 30 Gs. Deceleration is simply negative acceleration, so it's supposed to be 30 Gs. That's the acceleration. So 30 times g, which is 9.8. So since this is deceleration, supposed to attach a negative sign there. Okay, but it's all the same. So since we are saying undergoing this acceleration, but remember it's deceleration, so the negative just means the direction. Okay, so if you multiply 70 times negative 30 times 9.8, this is going to be negative 20,580 newton. So this is the force that is going to be acting on the person. It is negative because it's a force that is stopping someone who is moving. It's acting in the opposite direction. And the next person is what distance is traveled if the person is brought to rest at this rate from 100 kilometers per hour. We know that 2as is given by final velocity squared minus initial velocity squared. So this will be 2 acceleration is negative 30 multiplied by 9.8. This is the acceleration, no more than 30 g's. And it's negative because it is a deceleration. And this is going to be equal to final velocity, that is 0, is brought to rest. The initial velocity, we use the 1 meters per second, 27.78 squared. So we're going to divide both sides by 2 multiplied by negative 30 multiplied by 9.8. Also this side, 2 multiplied by negative 30 multiplied by 9.8. So this will give us, I left out an s here, 2as. So s, which is the distance, is going to be 1.31 meters. This is the distance that is going to be traveled before coming to rest. Well, that marks the end. Well, this is Assiduous Academy here. So if you are at any university, the University of Zambia, Copperbelt University, Mulongosho University, Cavendish University, we've got Mukuba, Levi Mwanawasa, you can register with us in any institutions which are conducted online, and well, you can contact us on this line if you want more details. Thank you so much for watching. Stay blessed.